Here is another scatter plot, and in this case you might be a little overwhelmed by how many data points this has. This has way more data points because it might not have been obvious what kind of pattern was being created when there were just a few points. There might have not been any correlation. But if you look at this now, it kind of looks like a necklace with a whole lot of jewels or something on it. It's a very interesting pattern that's being created. And if I were to try and draw a curve that would represent this, I'd probably draw something like this. You can see that if I draw those shapes, these shapes are representing these data points nicely. Notice that these have a parabolic shape to them. Now we have to pick which one of these curves that I just sketched would be the best fit to represent all the data points, not just a few. And so this can be the challenge, especially with regression, because it's a detailed calculation process. Fortunately, your calculator will do it for you. And if you have a whole lot of data points, that's even better because it can get tedious. That's a lot of data points. So let's just start off with the scatter plot, and I'm going to do my best to represent the data with a best fit parabolic curve, and this is what I come up with. Now, it looks like this parabola is centered about 0, x equals 0. So if I were to draw a vertical line at x equals 0, it would kind of split this parabola in half. So the parabola looks symmetric. It also looks like the x-intercepts are at about 1.2 and negative 1.2. And just to make this somewhat symmetric, I'm going to say that this x equals positive 1.25. I'm just going to go with 0.25. It's a nice quarter place. And let's make this one over here negative 1.25. And that's at the coordinate point x equals 1.25 and negative 1.25, y equals 0. That's along the x-axis. It also looks like this graph is shifted down. This graph looks like it's at about 0, negative 125. And now we can talk about how to write the quadratic. We know that a polynomial, f of x, can be represented by its zeros, where the function crosses the x-axis. And we know that that happens at two values, x equals 1.25 and x equals negative 1.25. We also know that the minimum when x equals 0, y equals negative 125. So we would need to figure out what scalar would have to go in front of this to make that true. So this will be a times x, let's see, minus 1.25 and x plus 1.25. And the scalar out front will provide us with that lowest value. Now I'm going to multiply these out. So I'll have a times the quantity x squared minus times a negative times a positive 1.25. Let's go ahead and calculate that really fast here. 1.25 times 1.25 equals, the middle terms drop out, by the way, when you multiply them all out, negative 1.5625. All right, so this helps me because I need to figure out what value would need to be in place of this number to give me negative 125. So let's see here. A times negative 1.5625 equals negative 125. So let's see what that would do. Well, we need to divide both sides by negative 1.5625. So I have negative 125 divided by negative 1.5625. So A equals 80. So my function would be 80 times x minus 1.25 times x plus 1.25. Now I could have also used this idea of vertex form, but you can also use this form right here. Now let's just, out of curiosity, graph this. So we have the graph f of x equals 80 times x minus 1.25 times x plus 1.25. And now I'm going to scale this just a little bit. It does appear to be a minimum at negative 125. And now I just need to scale this a tiny bit more. So let's make this from negative 6 to 6. Okay, that's better. So you can see that this does indeed represent the shape of the parabola. You're able to find the y-intercepts, which is negative 125, the x-intercepts, which is at negative 1.25 and positive 1.25. You can always check these calculations in Desmos afterwards just to make sure that you've used the correct math to get your answer. So now we're back to the scatter plot, and we need to answer the questions really quick here to get an idea of how to answer them, because this is parabolic instead of linear, and it's been a lot more work to get the function. So what's the trend line for this data? And we would say it's quadratic. And we could say it's opening upwards like that. What's the average rate of change? And we would say not enough information given. You could also say no points specified. For average rate of change. Both of those would be reasonable answers to that question. And what function type would this be? Well, it would be quadratic. It would have the form f of x equals ax squared plus bx plus c. And if you took the function we found, f of x equals 80 times x minus 1.25 times x plus 1.25, and you multiplied it all together, you would get a function in the quadratic form, in standard form, and you'd be done.